Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome back. Before I begin, I'd just like to tell you that there was no class on Thursday. Can you hear me? Yeah. So there was no class on Thursday because of the Blackboard login problem. I had a problem, many of the students had a problem, so we did not have a class on Thursday. So we'll be starting from where we had left off on Tuesday. Yeah, so no need to worry, Abdullah. Okay, in the last class we had looked at laws. We had looked at De Morgan's law and lots of other laws. So if you remember, I'll just refer a few laws. I'm sure you have them at hand. Okay, one of the laws was De Morgan's law. So this was one of the De Morgan's law. The other law was okay. So this could, it doesn't matter what P and Q are. They can be something like this. We just need to worry about the elements. We just need to worry about what is here and what is here. So this goes here and this goes here. Then we looked at lots of other laws, so you can have a look at them from your own screens and computers. Today we'll learn how to apply those laws. We will learn how to apply the laws. So you're given a question. Show that, for example, this is equivalent to this. Okay, we have an expression on the left and we are supposed to prove that it is the same as the expression on the right. We can do this using truth tables. We can have a column for P, a column for Q, and then we can calculate the column for the expression on the left. We can find out the truth values for the expression on the right, and if they match, we say that they are equivalent. So that's one way of doing it. But today we'll be looking at doing it or proving that they're equivalent using laws. Okay, so let's look at the expression on the left. Okay, is this in the form this, where A is something and B is something? So it's in this form, so we can apply De Morgan's law to this. So applying De Morgan's law, we get something like this. Okay, so we have not P or not, so we get this. Okay, where we see this as A and we see this entire thing as B. Okay, so this is our first step. Our first step, we got that. Second step, so this is our first step. Second step, this we write it like it is, or again in this expression again we can apply De Morgan's law. So we get not P is P, not P is P, or not Q. Okay, is step 2 clear? Okay, so only Hisham understood. Okay, let's move on to the third one, third step. Now this expression is in the form, I've made some mistake here. Who can tell me where's the mistake? The mistake is in this sign. This should have been and, not or. Okay, because there was an or over here, it had to be changed. Okay, so now this expression is in the form, it's in this form. So we apply the distributive law. Please have a look at your distributive law. in one of the pages. So distributive law, what does this give us? It says A and B or A and C. Okay, so that's the distributive law. So we'll apply that here. We get not P and P or not P and not Q. Okay, then the fourth step, what is not P and P? Not P and P. Not P and P is always false. Very good, Ali Habib. Okay, it's always false. Not P and P. No, Muhammad Ali. Yeah, it's false. Okay, false, or we have something here. Okay, what is false or something? False or something is the something. Very good. Yes, so we have not P and not Q. Okay, which is the same as the right hand side. So we proved this using laws instead of truth tables. So this is another way of doing it. Before I give you another example, I want you to try the same out. We'll be doing lots of examples, Ali Habib, but I want you to try this out again yourself on your paper. So make sure you get it and then you tell me, and then we'll take another example. Okay, I want you to solve this first on your paper and tell me you've got it, and then we can move on. It's only when you do you'll understand it. So please do it. I'll give you about 3 minutes, 2-3 minutes. Done, anyone? Okay, this could have also been done in a different way. So instead of looking at from the outside, I look at it from the inside. I'll try to solve this portion first. I'll solve the inner portion first. I'll apply the distributive law side. So what do I get? I keep the not like it is. So I get P or not P and P or Q. Okay, this is another way of doing it. I'm looking at applying the the distributive law first instead of De Morgan's. So what is P or not P? Always true. And P or Q. Okay. Now what is true and something? True and something is something. So I get P or Q. Okay. So then now I apply De Morgan's law to this. I get not P and not Q, which is the same as this one. So this is another way of doing it. So it depends on you. You can do it in whichever way you wish. Is that clear? Okay, let's take another example. Okay, let's take another example. What happened? Stop screen sharing. Just hold on. My screen has resized in a very strange way. Okay, someone has raised the hand and lowered their hand. Okay, no problem. Okay, let's take another example. Show that this is a tautology. Show that this is a tautology means show that this is always true. Okay, the easiest way I can do this is using the truth table, but I want you to use the laws. Show that this is a tautology. Okay, please don't look at the slides, you'll just get confused. So how do we approach this? We approach this applying the laws. Okay, so first law that we'll apply is this. If I have something like this, this is equivalent to not P or Q. Okay, is this one of the laws? Not P or Q. So this is one of the laws. Yes. Okay, so we'll apply that over here. So this entire thing is, think of this as P and this is Q. So we have not P and Q, not P and Q, or P or Q. Okay, so we've got rid of the implication. Yes, Ali Habib. We've got rid of the implication because implication is something that is a bit confusing and we are very comfortable with and or and not. So we try to remove everything that is not and or not, like bidirectional and XOR and the implication. So now we are comfortable. We just have a simple expression. So let's apply De Morgan to this portion, the one on the left. So we get not P or not Q or P or Q. Very good, Ali Habib. So we have this expression. Okay, now look carefully. Can we apply any of those laws over here? Look carefully and tell me if you can apply any of the laws. Search and tell me. All or. Yeah, very good. Good observation, Muhammad Ali. All or. So if you look at all or, it's like saying if you have an expression A plus B plus C plus D, okay, if we have something like this, we can move things around. We can say this is same as A plus B, same as A plus B, C, and B plus D. Can I do this? Move things around because all the signs are the same. So here I change the order. I move not P or P together, and I put the Q's together. Yeah, I can remove the brackets and move the P's together and remove the Q's together. So what is this? Not P or P and not Q or Q. What is the value of each of those? Very good, Ali Habib. So we get true or true. Very good. We get true or true, which is true, and proves that it is a tautology. Very good, very good. Most of you've got it. Very good. Can you do this again? Can you do this again without referring to the slides? So the question is, prove that this is a tautology. So please try to do this yourself without referring to the slides. Done? Let's take another example. Show that is a tautology. Show that this is a tautology. Can you do this? So let's look at it again. Let's get rid of the implication first. So we have something not left side or right side. Very good, Ali Habib. So we not the left side, which is P. And be very careful of the brackets. Don't remove them unnecessarily. So we've got rid of the first implication, the one on the right. This is the first step. Second, we can get rid of the other implication, the one inside. This becomes not P or Q. Okay. If you don't understand each step, please ask me. So I just removed two implications. So if we have an implication like this, it means not A or B. So I've applied that here, I've applied that here, both of those. Yes. Next, what do I do? Yes, Qasim, what do you prefer I do? Should I take care of the, apply the De Morgan's law first? Okay, I'll go with Ali Habib's suggestion. He says apply De Morgan on the left side. So I apply De Morgan, so this becomes not P or not. Okay, very good. Applied De Morgan's law. So I don't, just make sure you have your brackets right. We don't want to mix it up with your not P versus not P. Yeah. So now we apply De Morgan's law again. Again, this portion we apply De Morgan's law again only to that portion. So we have not P or not P is P, and that becomes and, yeah, and this becomes Q or Q. Okay. So far, so good. Now we apply the distributive law. We apply the distributive law on this portion. So it's like A or B and C. So we write it as A or B and A or C. So we apply it over here. So we get not P or P, and not P or not Q, and this whole thing in the bracket or Q. Okay, Ali Habib, very good. So not P or P. What is not P or P? Not P or P is always true. So this whole thing is true. I'll be skipping a few steps here. I will not write that. True and something. What about true and something? Is something. Very good. So this whole thing is equated to just the something part. So we have only this or Q. Okay, is the step clear? I skipped two steps. The first one was equating this to true and then true or something. Very good. Now if you look at this, we have something or something or something. So the brackets are not needed. If we combine this and this, we combine the second and the third term. So that's something or not something is always true. So this evaluates to not P or true. So something or true is always true. Okay, which means that we have proved that it is a tautology. Okay, is this clear? It will be clear only if you do it yourself. You have to do it yourself. You have to make mistakes. Yeah. So see, I removed the outer tautology, the implication first. You can choose to remove this first, or you can choose to do the De Morgan's first, or you can do it in different ways. So please try to solve the same problem again in your preferred way. Unfortunately, I can't walk up to you and see what you're doing, um, but I believe you're doing. So please try to do. Yes, I think the Blackboard was down again because I tried to log in from another device after I logged in into this. So there was a problem. Unfortunately, we cannot do. We have 17 students here. Maybe they can watch the recording. I think after 10 o'clock it went down. There's a problem now. Yeah, it is down. The login is down. So all those who logged in before 10:1 or 10:2 got in. After that, yeah, it's down. So those students, just tell them to watch the recording. Ali Habib. Okay, so it's back up now. It's back up now. It's just slow. Okay, so please try to solve this in a different way. Show that this is a tautology. You could have taken the implication first. Some students, yeah, you can go out step by step. So after you have removed both the implications, you should get this. Very good. Muhammad Ali solved it in a different way and got the same answer. Very good. Very good. So not P or Q. Yeah, you can get not P or not No, we did the same way, so let's do it in another way. So we'll keep this outside. So let's try the other way. So this becomes P and not P, or P and Q. So we have P and not P is false, and for or something is always false. So we get this. Okay, I skipped a few steps. You try not to skip steps. Okay, so this evaluates to false, and false or something is something. So we get this, and then continuing, we can expand this using De Morgan's law. And this, because it's all ORs, we can expand it. So we have not Q or Q will always be true, and true or anything will be true. So this is also a tautology. Very good, Ali Habib. I want others also to let me know. Now let me just check if all of you are awake or sleeping. Subhanallah, are you sleeping? Some of you answered yes. I've got 15 responses. One of them is sleeping, he said. What's the problem now? I have Ali Habib is very angry. It's turned purple. I don't know why. What's the issue with the blackboard? Ah, okay. Okay, hopefully the recording will help you. Yes, Mohammed, I told you that those who couldn't log in, they will have to watch the recording. I cannot stop the lecture right now. They will have to watch recording later. Those who entered early, Alhamdulillah, could get in. Okay, so 4 of you are really sleeping. I haven't got 4 responses. So I think 4 of the students are sleeping. So I don't know who they are. So it doesn't tell me. I request you to stay on and not sleep. Okay, so let's take another example. So the more you practice, the better you will get. Okay, now I'm looking at a very complicated looking example. I will have to write a small on this. I'll use a small font, so those who cannot see it, you'll have to zoom out. Okay, so we have 3 variables now, and we have a very complicated looking expression. Okay, regardless of how complicated it is, it still uses those laws. So all we need to do is just apply those laws. Yes, Ali, left side looks Okay, so the first thing, first hint, what we do is, yeah, it's an XOR. We remove the XOR and we remove the implication. So let's get rid of the XOR first. So if you look at the laws, you have two rules that you can use for XOR. You can use either one. So we will just expand the XOR. So this is P or R and not P and R. So I expanded the XOR. Okay, so I used one. There are two ways of using or expanding the XOR. So I used this one, P or R, and not P and R. Yeah, so you can use either one. And in the same step, I'm removing the implication also. So this changes the first term to not P and not Q. And so I've skipped one step. So after this, I should be able to get this. Okay, is this clear till here? So we use De Morgan's and the XOR. We have two terms. Let's bring the not into the, so let's look at this term now. Let's look at this term. So I bring not inside. So this, applying De Morgan's law, I get this. Yeah, very good. Not P or Q. Very good, Ali Habib. And here, what can I do with this? What can I do with this? I'll apply De Morgan's law again inside. So I have P or R and not P or not R. Okay, so I've got rid of whatever I could do to expand. So this is what I have now. And now I am stuck. Now what do I do? So I cannot remove the brackets because it's inside. So what do I do? Okay, now from here I require a bit of intelligence, a bit of thinking what I can do. Stuck here, so I have to look beyond the laws. I have to look a bit beyond the laws. So let's see what I can do. So if you look at this statement, okay, it is similar to A or B or C, where C is a big expression. So I will do an interchange of these two. I'll interchange these two and then use my distributive law to open it up. Okay, so this becomes Q or not P. Why? Because P I can apply inside. Okay, if I push Q inside, there is no use. So I bring the P together. So I apply P, I apply P on that as using the distributive operator. So I have Q is like it is. So I get P in the first term. So I get not P or R as my first term and not P or not P or not R as the second term. Is this clear? Be very careful with the brackets. The little missing or the little moving of the brackets, you get a wrong answer or an incorrect answer. Okay. So now if you look at this, we have an OR and we have an OR in this bracket. We have an OR and we have an OR. So not P or P. Yeah, this last step is I applied this law over here. A or B and C. No problem, Sadhan. Many of us were having problems last week also. So Alhamdulillah, 21 joined in. So those who've missed the initial portion, don't get scared looking at this. What I suggest is you just uh, go to sleep right now, and then watch the whole session right from the beginning, because if you see this right now you might get scared. I don't want you to get scared. For those who have attended from the beginning, they know we went step by step. It is not difficult. If you look at this slide, you will get scared. It is not scary. It is easy. Oh, very good, Faisal. Very good. Okay, so you can watch the recording later, inshallah. And if you have any questions, please ask me. I don't want you to get scared because this is not scary. For those who joined late, I'm sure you'll find all these things scary, but it's not scary. We're doing it step by step. If you get scared now, everything else will be. Yeah, Muhammad Ibrahim, that is another case. So it's just that you need practice. We will work on this again and again and again so that we get a bit confident. We'll be doing this in the tutorial also. Okay, so those who are brave enough, continue with me. So after we applied this, we got the last step. Now we are looking at the ORs. I'll do this again in the next class, inshallah. So don't worry. I will take up smaller problems again, and we'll do it again, inshallah, in the next class. Okay, so let's look at this. So we have Q or. Now we have not P or P, which is always true. True or something is true. So this whole expression evaluates as true. So we have true and something. True and something is something. So this whole expression again evaluates to this portion. And this portion, if you look at this, we have a not P and a not P. Not P or not P. So not P or not P is not P or not R. We have not P or not R. Okay. So now we have an OR outside, we have an OR, we can rearrange. So this rearrangement gives not P or Q or not R, which is the same as the right hand side. Yes, Sultan. So this is what was required, and that's how we got it. Okay, what I'll erase this. So the basic rules we used over here, we used the XOR, we used the implication, we used the De Morgan's, and we used the distributive law. Okay, so we are just looking at applying those laws, and then we also used a very simple law. Rearrangement. A or B is the same as B or A. So we used this law, and we used two more laws. Not A or A is always true, and not A and not A is always not A. So simple laws like this. So we use lots of laws, referring and then applying. So that's all there is to it. Okay, I will solve it again. Applying the laws, we'll just solve it again. So we've been asked to prove that the left hand side is equivalent to the right hand side. Yes, Faisal, so both of them are equal. So how do we start off? We can start off with if you look at, I'm sorry, I keep hitting that erase button by mistake. Okay, we will solve this by applying the law for the XOR and the implication. So with implication, when I apply the law for implication, it gets OR and that expression. Okay, and that expression, there are two ways we can expand it. We'll use one of them, which is P or R, and not P and R. Okay, so the second step was basically removing the implication and the XOR operator. I've combined two steps here. I request you not to do that because here I have a shortage of the whiteboard. I'm limited, that's why I'm doing it. If I was doing it in the college, I would have done every step as separate. Okay, here I'm limited by space, so you don't do that. Don't skip steps. Okay, now what do I do? Now I did that again. I keep making that mistake. I keep making that mistake because it's very close to the change color button. And whenever I want to change color, that looks, I don't know why that looks like change color to me. Okay, so we expanded this, this. Okay, so we got this. Now I'll apply De Morgan's on the left side. So I get not P and Q, or I write the expression unchanged. I apply De Morgan's again on this side. Okay, so I get the third step. Okay, so I'm stuck over here. I cannot use any of the laws. So I use my intelligence. I say, okay, this looks like this, and this expression, something, no, this has to be or. Okay, something or something or something. So if I have ors as the same terms, I can do an interchange. So I interchange these two, because if I use Q, and here I have just P and R in this expression, so it will just complicate it. If it just complicates it, it's no sense expanding it using distributive law. So instead of that, I use some logic and I say, okay, let's interchange them and apply P inside. So which is what I do. I keep Q outside and then apply. So it's P or I have two terms. So I just apply the distributive law on that. So I have P or R as one term and P or not R as the second term. Okay, I get two terms from this. So P or P, I've made some mistakes here. So it's not P over here. I'm sorry, it's not P. Okay, so not P or P. Not P or P will give me a true. Yes. And a not P and not P will give me a not P over here. And true or R will give me a true. Okay, and this whole thing is true. So true and something is something. So the whole expression evaluates to not P or not R. Okay, so I get this. Okay, now this still is not the final answer, because in the final answer we have P first, then Q, and then R. So we just rearrange because it's all, we have OR in between. So we get not P or Q or not R. Okay, so we've got the same answer as on the right hand side. Okay, so I request you to try these again. We've used one way of expanding XOR. Try to use the other way of expanding XOR. You'll still get the same answer. Inshallah, the next class we'll be taking a few more examples so that we understand how to prove equivalences in a better way. We'll take some examples from the textbook. I can do many examples over here, but watching me do, you will not understand. Unless you do and stuck, you will not be able to really appreciate the way it's done. So I request all of you to practice what we've done to get more confident. This as you get confident, it become easy, and this is also a question that you will be asked in both your midterm and the final. And it's an easy way of scoring, because we give most of the difficult things that you cannot remember, the laws. So you just have to look and apply the laws. So with this, I'll stop for now. So those who joined late, please watch the lecture again and try to understand and try to work out things on your own. I'll also repeat this, not repeat this, we will do similar problems in the next class so that we get more confident. And those who did not have the set of slides with them, the formulae, I request you to please bring those formulae with you when you sit down to watch this. Get the formula sheet, get a piece of paper and pencil so that you solve it with me or before me. I've noticed some of you are solving it before me, so that's what I expect. If you solve it before me, you'll get more confident. Don't wait for me to solve. So in the next class, inshallah, we will revisit this section again. That's all for today. I'll stop the recording now. Assalamu alaikum wa rahmatullahi wa